Hello and welcome into the example video for lesson 7. In this video, we're going to be taking a look at a bunch of different examples for our systems of equations. So systems of linear equations, nonlinear equations, and then multiple variables. Share. Oh, and this is for Precalculus 1, by the way. Okay, so the first couple videos, or first couple problems rather, are going to be our system of linear equations. So we want to solve. We're given x minus y is 10 and 5x minus 4y is 42. So recall that we can do one of two things. We can do substitution, we can do elimination. And so in this case, because the first equation has coefficients of 1, what I can do is I can add y to both sides, and I get x equals y plus 10. And then this I can now substitute into the second equation. So we get 5 times x, which is y plus 10, minus 4y is 42. Distribute our 5. So 5y plus 50 minus 4y is 42. Subtract 50 from both sides. You get negative 8 on this side. And then over here, I have 5y minus 4y, which is just 1y. Therefore, y is equal to negative 8. Plug it back into either equation. So I'm just going to use the first equation, the original equation. So I have x minus y. So x minus negative 8 is 10. So that's x plus 8 is 10. Subtract 8 from both sides. X is equal to 2. So my answer here would be 2 and negative 8. And again, recall, if this is on an exam, you can check your answers. Plug them into the equation. So x is 2, y is minus 8. 2 plus 8 is 10. That's true. Plug it into the second one. 5 times 2 is 10. Negative 4 times negative 8 is plus 32. 10 plus 32 is 42. So I am 100% sure that problem is correct. I can't wait to turn in my exam and get all my points for that question. Second example, we have 3x minus 2y is negative 22. And negative 9x plus 8y is 76. So in this one, it's a little bit more difficult to use substitution because I can't really get like x equals something or y equals something and have nice values. I could get fractions, but I really don't want to deal with that. So instead, I'm going to look at the x variable here. I'm going to use elimination method, which means I want these to be the same. Well, if I multiply this first row by 3, this is, sorry, not the same, but opposite, have opposite coefficients. So if I multiply this first row by 3, this gives me a 9x. 9x minus 9x is 0. So that's what I'm going to do here is multiply this row by 3, the top equation. So I get 9x minus 6y equals negative 66. Remember, you have to multiply every term and constant by that value 3. And leave the second one alone. So negative 9x plus 8y equals 76. Add down 9x minus 9x, gone. 8y minus 6y is 2y. 76 minus 66 is 10. Let's divide everything by 2, says y is equal to 5. Plug it back into either equation. So again, if I just use the first one, 3x minus 2 times y, which is 5, is negative 22. So 3x minus 10 is negative 22. Add 10 to both sides. 3x equals negative 12. So divide by 3. X is equal to negative 4. So your answer then is x is -4, y is 5. And it'll usually say like enter your answer as an ordered pair or an ordered triple. If we have 3 variables, that's what it means. Our next equation, or sorry, next system of equations. We have y equals x squared and y equals x plus 20. So I could move the x squared over. I could move all of these guys over, do elimination. But in this case, it's easier. Just use substitution, plug in x squared for y. So when I do that, I get what? I get x squared on this side is equal to x plus 20. So subtract x and subtract 20 from both sides. I get x squared minus x minus 20 is 0. This will factor for me into x minus 5, x plus 4. So by 0 property rule, x is 5 and x is -4. So now I'm going to have a couple solutions. First, when x is 5, plug that into either equation. So probably the first one is easiest. Y is equal to x, which I'm saying is 5 squared. So y is 25. So one answer is 525. My second one, when x is -4, again, if I just plug it into the first one, y is equal to x, -4 squared. -4 squared is 16. So my answer is, sorry, -4 positive, what am I doing here? -4 positive 16. And again, you can check them. If I plug it into the second equation, 25 is 5 plus 20. That's true. Plug it in here. 16 is -4 plus 20. That's true. So I know both of those answers are correct. What if I have x squared minus 3y is 13 and x squared plus 3y is 37? So in this situation, the way this is given to us, elimination is absolutely going to be the easiest way. Why? Because these guys are already opposites. And so all I really have to do is add down, but be careful here. X squared plus x squared is 2x squared. -3y plus 3y is 0. 13 plus 37 is 50. So divide both sides by 2. We get x squared is 25. And that means what? X is plus or minus. This is our not so simple quadratic because everyone usually gets it wrong. Plus or minus square root of 25. So x is equal to plus or minus 5. So again, first, if x is equal to -5, what does that give us? So we plug it into either one. If I plug it in this first one, I have -5 squared minus 3y is 13. So we have 25 minus 3y is 13. Subtract 25 from both sides. -3y is equal to -12. Divide by -3, y is equal to +4. So one answer is -5, +4. And now when I do x is equal to 5, well, let's look at this. Here I plugged in -5, but because I squared it, I ended up getting 25. So I'm going to get the same answer, right? Because now it's just +5 squared minus 3y is 13. And so 25 minus 3y is 13, which is exactly what I have on the other side here. So all the rest of this is going to be the same, meaning y is 4 in this situation. So my answer is +5, +4. So those are the two solutions for that one. All right, so that was our systems of equations for linear system and system of nonlinear equations. Now comes the big one, right? Our system of multiple variables. So we want to solve x minus 2y plus z is 1, 3x plus y plus 2z is 4, and negative 2x minus 3y plus z is negative 5. So if you remember, ideally we want what? A 1 in the upper left. Well, when I convert this to an augmented matrix, because this is a 1, that's what I'm going to have. So I'm just going to leave everything as it is. So 1, negative 2, 1, 1, 3, 1, 2, 4, negative 2, negative 3, 1, negative 5. So first thing we do, we want to try to get a 0 here where this 3 is at. So I'm going to do row 1 times something plus row 2 to give me a new row 2 with a 0 there. So I'm going to have to do what? Multiply this by negative 3. And that's why having a 1 here is so nice, because I just use the opposite of whatever's here, right? So I get what? I'm going to leave the first row alone the whole time. So negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times negative 2 is positive 6 plus 1 is 7. Negative 3 times 1 is negative 3 plus 2 is negative 1. Negative 3 times 1 is negative 3 plus 4 is positive 1. Now I want row 1 times something plus row 3 to give me a new row 3. And I want to get a 0 down here where there's a negative 2, meaning I have to do what? I have to multiply row 1 by positive 2. So when I do that, 2 times 1 is 2, minus 2, 0. 2 times negative 2 is negative 4, minus 3 is negative 7. 2 times 1 is 2, plus 1 is 3. And 2 times 1 is 2, minus 5 is negative 3. So now my goal is what? To get a 0 here using row 2. Well, we can see what? They're already the opposite, right? So if I do row 2 times 1 plus row 3 gives me my last row 3. So I have 1, negative 2, 1, 1, 0, 7, negative 1, 1. And again, I'm just going to add it. 0 plus 0 is 0. 7 minus 7 is 0. Negative 1 plus 3 is 2. 1 minus 3 is negative 2. Whoops, sorry. Let me move that up. Sorry about that. Let me do it again. So I'm adding them. 0 plus 0 is 0. 7 minus 7 is 0. Negative 1 plus 3 is 2. Negative 1 minus 3 is negative 2. And now we have what? We have one row with 1 0, one row with 2 zeros, and we do what? Get the H out of the matrix, right? So if I use this last row, this really means what? This means 2z is equal to negative 2. So divide everything by 2 means z is equal to negative 1. Now use the second row, because this second row means what? 7y minus z equals 1. So plug that in here. I get 7y minus a negative 1 is 1. So 7y plus 1 is 1. Minus 1 from both sides, 7y is 0. So divided by 7 means 0 divided by 7 is 0. And last but not least, use the first row. I'm going to do it over here because I'm running out of room at the paper here. So x minus 2y plus z is 1. So x minus 2 times 0 plus z, which is negative 1, is 1. So x, negative 2 times 0, 0 is gone. Minus 1 is 1. Add 1 to both sides. X is equal to 2. So your answer as an order triple is 2, 0, negative 1. So that's how we do a system of multiple variables. With those, it's just a lot. Practice makes perfect. And if you guys come to class, I will show you the spreadsheet I have uploaded to Canvas, which will allow you to practice as many of these as you want until you're really, really good at them. So the first video was a little bit longer. This one, not quite as long as far as the examples go, but it gives you a taste of everything. Substitution and elimination with linear systems, substitution elimination with your nonlinear equations, and then finally, system of equations with more than two variables. So come on back and we will tackle lesson number 8.